One of the most common errors in simplifying radical expressions that include fractions especially is that people incorrectly try to reduce these fractions by canceling parts of terms. And just as you would never take a fraction, for example, like 5 plus 2 divided by 5, and then say cancel the 5 and make the answer 2, you would not want to just simply cancel the 5's here because of this additional term. And there are correct ways to reduce this fraction, but we have to be careful to use them. So we can choose one of these two methods. One says factor the top and the bottom, then cancel. So in the numerator, the 5 square root 3 and the negative 10 both have a common factor of 5. So I can pull that out, and now the two terms remaining inside are the square root of 3 minus, and then 10 divided by 5 gives us 2. So this is still divided by 5. And now this 5 is not part of an added term, but it is actually a multiplied factor. So while I would not be able to cancel the 5's in this expression, if I did have something like 5 times 2 divided by 5, this would be allowed to be canceled to give us a resulting value of 2. And if you kind of think of it in its original form, 5 times 2 would give us 10 divided by 5, which is equivalent to our answer. So we really are allowed to cancel out the factors of 5, again, because they are factors, they are multiplied. In the denominator, the 5 is multiplied by a 1, which is implied. And so what we're looking at is just square root 3 minus 2. You can think of that whole thing being divided by 1, but simply the square root of 3 minus 2. In the second fraction, again, we cannot simply cancel out factors of 3 because we have a subtracted term here. But what we can do is try to simplify the radical. So when I look at this radical, I think, what perfect squares are factors of 72? It is true that 4 is a perfect square that goes into 72, but so is 9. And as you kind of think through the various perfect squares, 4, 9, 16, 25, and then 36 actually is the product of 4 and 9, and that also is a perfect square. So I want to separate this square root 72 into its perfect part, square root of 36, times its non-perfect square part, which is 2. And so this is just the leftover. And these two terms are still divided by 24. So let's continue to simplify this. The first term is still 15, but the second term, the perfect squared part, will now change from a radical into a non-radical. Square root of 36 is just equal to 6. And the square root of 2, that 2 is still on the inside, whole thing divided by 24. Now we could go back and do this problem by method 1, where we factor this numerator, taking out a common factor of 3. But another way to do this problem is to separate the numerator terms, putting each term over its own denominator. So I can think of this fraction with two terms as being 15 divided by 24 as the first term. And then the second term we've got here subtracted, so we've got minus here, 6 times the square root of 2, also divided by 24. And now these are each their own separate fraction, so we can reduce common factors. And when I divide by 3, I've got 5 here, and dividing by 3, I've got 8, so the first term becomes 5/8. And then minus, and 6 and 24 both have a common factor of 6, so I've got 1 remaining in the numerator times the root 2. So let's make that the square root of 2, divided by, and then 6 goes into 24 4 times. So we've got square root of 2 divided by 4. Now, if we had done this problem by factoring, we could pull out again that common factor of 3, and what we would have is 5 minus 2 square root 2, whole thing divided by 24, and dividing by a factor of 3, then we've got this numerator divided by 8. And this looks slightly different from the second way that I wrote this expression. However, if I wanted to, I could build this second fraction up to a denominator of 8 by multiplying the numerator and denominator by 2. And in this case then, I would end up with that common denominator of 8 for both terms, and the first term is 5 minus, and this whole number 2 I'd bring out to the front as a multiplier to root 2. and now I do have the same appearance as the other answer.